Hey scholars, it's Mrs. Gregerson and we are working on our special right triangles, and this is still based off of the Pythagorean theorem. This only works for right triangles, and remember Pythagorean theorem, you have to know two sides. Well, we have what are called special right triangles, and one of the special right triangles is a 45, 45, 90. When we know this, if we look at it carefully, if it's a 45, 45, 90, our two acute angles are both 45 degrees. Well, knowing what we know about the three bears or even isosceles triangle theorem, if these two angles are congruent, what two sides are the same size? Yeah, the two legs are the same side. And so obviously that means they would have to be equal. Now we're going to use the fact that they're equal to develop patterns to work for any isosceles right triangle. And by the way, 45, 45, 90 and isosceles right triangle are interchangeable terms, so we know they mean exactly the same thing. So we're going to use this to kind of develop and use inductive reasoning, remember developing a pattern, to figure out the measures of sides. So here's our first one. We know this is 45 degrees, which means our other angle is 45 degrees. Those two sides have to be the same. So now I can use the Pythagorean theorem to solve for the missing side. Leg squared plus leg squared equals hypotenuse squared. So I get 5 squared plus 5 squared equals my hypotenuse squared. So 25 plus 25 equals c squared. I get 50 equals c squared, and then I take the square root of it. Well, what's my largest perfect square number coming out? That's 25. So what's the square of 25? So it'd be 5. So it'd be 5 root 2 is our hypotenuse. So right here it's 5 root 2. Okay? So now let's try it again with this one. The same idea holds as before. My two legs have to be the same size. So we're going to use our Pythagorean theorem. Again, leg squared plus leg squared equals hypotenuse squared, and we're just going to solve for the hypotenuse. And we go 6 squared plus 6 squared equals hypotenuse squared. So we got 36 plus 36 equals our hypotenuse squared. That's 72 equals our hypotenuse squared. And then we take the square root of both sides. Again, you should have a plus or minus there, but we're doing length, so that's going to be a positive, not a negative value, so we don't have to put the negative sign. And that, again, simplifies into the square root of 36 times the square root of 2. What's the square root of 36? 6 root 2. And so this side's 6 root 2. Can anyone guess probably what the other two sides over here are going to be? The legs are going to be the same, right? And so we know that they're both 7. And what do you think your hypotenuse is going to be? If you said 7 times the square root of 2, you're right, but let's go ahead and confirm it with our results here. So we have a squared, leg squared, right, plus b squared, which is also leg squared, equals hypotenuse squared. 7 squared plus 7 squared equals hypotenuse squared. 49 plus 49, that's going to be 98, equals c squared. Square root it. The perfect square number that comes out is 49 times the square root of 2. So it'd be 7 root 2. So you're absolutely correct if you said the hypotenuse is 7 times the square root of 2. So it's always the longest. And so we should be able to develop a pattern based off of what we know with these. So let's go ahead and let's think about it for a moment. So with this, we're going to call the different parts. This is right here. In a 45, 45, 90 triangle, both legs are congruent. So we know this is true, right? And it says the length of the hypotenuse is the length of the leg times root 2. So when we do this, you should have x and x for your legs. And then if I'm going to do a generic way of doing this, I'm going to go x times the square root of 2. Now how do we say this? We can go leg and leg are both equal to x. And the hypotenuse is going to be the leg times root 2, so x root 2. Now some people like writing it like this. Hypotenuse equals leg times root 2. It's just a way of thinking about it. Now I use variables for these because this is what you'll see on like the SAT and PSAT, but I want you to think a couple different ways. When you are working, okay, you are going from a smaller side to a longer side, you will always multiply. So notice when I'm going from the leg to the hypotenuse, I multiply by root 2. But if I'm going from the hypotenuse to a leg, I divide. All right, so you divide by it. So just remember the direction that you're going. It'll help. Now, here's the thing. You want to memorize these triangles as much as possible because it will help you keep things straight and keep a pattern, because this pattern holds true no matter what the radicals are for every single isosceles right triangle. All right, so we're going to go ahead and we're going to start applying what we know to the back side.